Hello everyone, today let's solve the problem number 1899, merge triplets to form the target triplets, right? So let's see what the question states here. So we have been given triplets, nothing but the list of ABC, right? You can clearly see here ABC 253 ABC 184 25 this one 175, right? Also we have been given target XYZ, right? So see here 275, this is nothing but the XYZ. We can repeatedly replace a triplet by element wise max of 2 triplets, right? So we can repeatedly replace a triplet by element wise max of 2 triplets. So we have to return true if we can make the target appear among the triplets, otherwise we have to return false, right? So we have to return true if we can make the target appear among the triplets, right? So otherwise we have to return false. So all the values are positive integers and merging only increases components, right? So this is fine. Now let's come to the example part here. We have 253 184 175 and the target we have been given here 275. In this case we have to return true because so we have to perform the following operation. See here, we have to choose the first and last triplet, right? So this one 253 and 175 among 3 triplets. We have been given 3 triplets here. We will be choosing first and the last one. Then we will be updating the last triplet to be the max, right? So max of 2 comma 1 and 5 comma 7, right? So here this one 2 comma 1 5 comma 7 and this one 3 comma 5, because we are considering the first and the last triplet, right? See here, so this one 2 1 5 7 and 3 5, right? So max of 2 1 is nothing but 2, max of 5 7 is 7 and max of 3 5 is 5, right? So this one we have got this one 2 7 5, max of 2 1 is 2, 5 and 7 is 7 and this one 3 and 5 is 5. So we have got the output 275. So triplets that we have here is 253 184, instead of 175 we have this time 275, right? So the target triplet 275 is now an element of the triplet. So the same thing we have to apply the same thing for the example 2 and example 3. For the example 2 it is not possible, so in that case we have to output false, and I insist you to try out for the example 3 in this case, right? So you'll get to understand. So now we have the understanding of the question. We have seen the example. They have given us wonderful examples just for the sake of understanding. Now let's do one thing. So let's understand one thing, that we will be going with a greedy approach to solve this particular problem, right? So I'll consider the same first example for the approach, right? So first step here, we will be going with, let's go with the 3 steps: step A, step B and step 3, right? Step A is we have to filter the valid triplets, right? So we have to keep only the triplets whose every component is less than or equal to the corresponding target component. In the sense 2 comma 5 comma 3 is valid, meaning 2 less than or equal to 2, 5 less than or equal to 7 and 3 less than or equal to 5, right? So this is the reason 2 comma 5 comma 3 is valid, right? So 1 comma 8 comma 4 is also valid, right? So 8 is less, this one 8 is greater than 7 here in this case. So basically 1 comma this one 8 comma 4 is also 1 comma 8 comma 4 is invalid. 2 comma 5 comma 3 is valid. 1 comma 8 comma 4 is invalid because 8 is greater than 7. So I'm thinking another thing. See here, 1 comma 8 comma 4 is invalid. This is fine. So 1 comma 7 comma 5 is also valid. So this 2 comma 5 comma 3 is valid. This one is also valid. So this 1 comma 8 comma 4 here is invalid, right? So because 8 is greater than 7. This is step A, right? So from the step 1 or the step A, the invalid one is 1 comma 8 comma 4 here. This is fine. Now let's move on with the step B, right? So we are done with the step A. Let's move on with the step B. So in the step B, from the valid triplets, so what are the valid triplets? We have 253 and 175, right? So now we have from the valid triplets 253 and we have one more valid triplet, nothing but 1 comma 7 comma 5. This is fine. Now let me tell you one thing. We have to filter the valid triplets, meaning only we have to keep the triplets, sorry, not this one. From valid triplets we have to greedily collect whether any triplet provides each target component exactly, right? So 2 comma 5 comma 3 gives x equals to 2, right? So 2 comma 5 comma 3 gives x equivalent to 2, right? and we have to mark found x, right? Also 1 comma 7 comma 5 gives y equals 7 and z equals 5, right? So this one 1 comma 7 comma this one x basically, and here this gives y equals 7 and z we have 5. This is nothing but this one xyz sorry, y equals 7 and z equals 5 here in this case. This is fine. So y I have considered x from b and x from 2 comma 5 comma 3 and y z from this one 1 comma 7 comma 5. I'll tell you here. So this one, see, this x equals to 2, we will be marking this one as found x, right? This one will mark this one as found y and found z, right? So now this is required in the step C. See, now what we will do in the step C, so if the found x and found y and found z, all the three values, right? So now we have 2 this one and 7 value 7 and value this one 5 basically. X, found y and found z. If found x and found y and found z, then we can merge those contributors, right? So via element wise max, right? So to form basically what we need to form 275, right? We have to form 275. So here all three flags are true. Here all the three flags are true, this one, right? So then we can form this one, what do we call this one 2 comma 7 comma 5 here. All the three values are true, all the flags are true here, so we can just consider this one 2 comma 7 comma 5. Consider in the sense, then we can merge those contributors basically via element wise max to form 2 comma 7 comma 5 within the array. So this is basically the greedy idea, right? So we are keeping only non-overshooting triplets and we are checking whether all the target components can be supplied or not here. Simple terms, in simple terms I have said this, right? So and we have got the output 2 comma 7 comma 5 here, so which is equivalent to the output, sorry, which is equivalent to the output that they have got here, right? So 2 comma 7 comma 5. Now 2 comma 7 comma 5 target can be formed here. So in that case, so what we need to return, we have to return true, right? So here all the flags are true, so what we will do, we will return true. So the output, final output that we got here is true, which is equivalent to the output that they have mentioned for the example 1 within the question. Now as we are completely familiar with the question, this one approach, we are good to write the, let's discuss the complexities and then let's write the code. So what will be the time complexity and the space complexity here? The time complexity would be big of n here. So why the time complexity here would be big of n? Because we will be going with a one pass. Basically we are making use of the greedy and we'll be going with a one pass over n equals triplets dot length, right? So this one triplets, n equals triplets dot length, right? So constant work per triplet basically in simple terms, right? So overall time complexity would lead to big of n. So what would be the space complexity here? The space complexity would lead to big of 1. Why? Because only we'll be making use of only few boolean and int temporaries regardless of the input size. So overall space complexity would lead to big of 1. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of 1 and big of n and big of 1 respectively, right? So now as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So first thing, now let's go with the 3 flags, right? So flag 3 flags means we have, if we have already found a triplet, then we can supply target of 0 exactly, right? And all same goes with the target of 1 and target 2, right? So we have to go with the flag this one, if we have already found a triplet, then we can supply target of 1 as well, and same goes with the target of 2 as well, right? So let's write the same thing in the form of code here. So this one boolean fx, let me set this one to false, right? So let me copy the same thing twice here. So instead of x, let me make this y, instead of y, let me make this set. Let me make this set. This is fine. Now after doing this, let's iterate through every triplet once, right? So as we had discussed, we'll be going with the greedy approach, right, or the greedy single pass here. So let me go with a for loop here. So this one int I equals 0, I less than let me copy this one, length of the triplets, right? So this one triplets dot length and I plus plus. So within this for loop, So let's read the first component of the current triplet, then first, second and third component of the current triplet, right? So let me consider the variable a, b and c for that, for the first component, second component and third component respectively. So I'll just go with a equals triplets of I and 0, right? So let me copy the same thing and paste it over here twice. So this one, let me change this one from a to b, change this one from a to c. So this one has to be I, this is the first component I1 and this is the second component I2. Sorry, second and third component. Basically indexing we are going from 0, right? So that is the reason 0, 1, 2. This is fine. Now what we need to do, so if any component is greater than the target's corresponding component, then this triplet can never be used, right? It would overshoot. Then we have to skip that. For skipping, we can just make use of the continue keyword here in the Java. So I can just write it on this way. If a greater than target of 0 or b greater than target of 1 or c this one greater than target of 2 then within the if condition, let me give continue here. So this is fine. Now let's do one thing. So if this valid triplet exactly matches target component at the position 0, we have to mark fx. Same goes with the second and third component as well, right? So if this valid triplet exactly matches target component at position 0, then we have to go with then we have to mark fx. For the position 1, we have to mark fy, and component at position 2, then we have to mark fz, right? Same thing. Let me write the 3 if conditions here. If a equals target of 0, this is fine, then let me assign fx to true. Let me copy the same thing again. Let me copy the same thing twice here. This is fine. Now this one, let me change from a to b. Let me change this one from a to c. So this one has to be target 1 and this one has to be target 2. So this one has to be fy and this one has to be fz. So all the 3 things are true basically. Right, so this is fine. Now yep, this is fine. Now if all the 3 components can be supplied by this one valid triplets, then we can merge those contributors to obtain the target, right? So in that case, if you remember, that's the last step, right? So that we discussed on the approach. So I can just write it in the form of code in this way: if fx and fy and fz. So this one, then we have to return true. That's what we did, right? So this is fine. Now finally sorry, yeah, now finally what we need to do, if after scanning all the elements we didn't find the contributors for all the components, then it is impossible, right? So in that case we have to return false. So I'll just go with return false. This is fine. Now let me format the code once and let me hit the run button. Just give me a second here. Yep, you can clearly see here the sample test cases are getting passed. So let me hit the submit button. I hope this works for all the test cases, man. So yeah, you can clearly see here all the test cases are getting passed. Means whatever the code that we have written works absolutely correct for all the test cases, right? So I hope the solution part is completely clear along with the approach as well as the complexities. For now, this is it. Thanks for watching, guys.